So good afternoon, students. Uh, are you able to hear me? Am I audible to everyone? You can write on the chat box or you can give me a thumbs up. Am I audible to you? Okay, thank you. Thank you, Raghavi. So, yes. So good afternoon, everyone. So I am Sunit Kumar. I am your physics teacher. I'll be taking your physics classes during this summer course. I have done my engineering from BITS Mesra, and I have around 20 plus years of teaching experience to foundation grades as well as JEE and NEET students. Okay, so let's start the class, students. So the first chapter which we are going to do in class 10th is light, reflection and refraction. So there are two topics which are related to each other, light and human eye. So these are two related to each other. And then we have two other chapters, electricity, current electricity and magnetism. These are two other chapters basically. So which we'll pick up later. So we'll start with light, students. So what are the prerequisites? Prerequisites as in what are the concepts which you should know before attending this class so that you understand the concepts well. So first, you should have basic understanding of mathematics, basic mathematics. Second, plane mirrors. You would have studied plane mirrors in class 7th and 8th grade as well, right? So we will first of all, in today's class, we'll recapitulate all those concepts which you have studied in earlier classes as well, because, understanding the law of reflection on plane mirror helps you understand the law of reflection for curved mirrors, spherical mirrors as well. So plane mirrors will start, and then we will understand the concept of object and image, right? So these are the three prerequisites which would be needed for you to understand the chapter well. So weightage of this chapter in boards, class 10th CBSE boards is 10 marks. So 10 marks question comes from this chapter. So it is a very important chapter. So if you see out of 80, if 10 marks are coming from one particular chapter, that is an important chapter. So the theory questions, the numericals, both come from this chapter. So we will focus on both of these. Now, let's understand what we are going to do today in today's class. As I said, we'll start with the concept of plane mirrors. Second, characteristics of image formed by the plane mirrors. Third is to understand the law of reflection. So these are the three things which we are going to do in today's class. Now, let's first of all understand what is light, right? So you can see that, whenever you switch on a light, in general perception, when you switch on a light, you are able to see things clearly. How does it happen? So light falls on an object, and then after reflection from that object, you are able to, the reflected light helps you see an object. So if there is no light in a room, you will not be able to see anything. That is because there is no reflection which is happening. So light, let's say from a bulb or a tube light, falls on an object, and then the reflected light from that object helps you see the object clearly. Okay, so this is the basic concept which you already know from your previous grade. So what is light? Basic definition of light is a form of energy which enables us to see objects from which it is reflected. So it is that form of energy which enables us to see the objects from which that light gets reflected. So you will be able to see the object only when light is reflected from that. If there is no light reflected from an object or no light which is falling on that object, you will not be able to see that object. Is it clear? So when I ask you, is it clear? You can always raise a thumbs up or say yes in the chat box so that there is an interaction going on between me and you students. Okay, thank you students. So light travels in a straight line, which is also known as, this property is also known as rectilinear propagation of light. So this property of light, which tells you that light travels in a straight line, this particular property is called rectilinear propagation of light. Is it clear? Now, so if you want to write, you can, keep on writing your notes, because, once you write the notes, first, you are involved in the class. Second, you are prepared for your exams. When when you are revising, you can just go through the notes which you have made in the class, so that you can revise it before your exams. So it will help you, remember whatever we have taught, whatever you have learned in these summer courses. Okay. So always keep a, notebook with you, and please scribble these notes so that it helps you revise later on. Okay, student. So first thing, light is a form of energy which enables us to see objects from which it is reflected. Second, light always travels in straight line, and this property is also known as rectilinear propagation of light. So you can see that, whenever light will propagate, it will be in a straight line. So light is a form of energy that produces the sensation of vision. It's the same thing which we have done in the previous slide. Rectilinear propagation, as I said, means move, when the light travels, it will travel in straight line. You can see this example. Here the light is coming from a small window, and you can see that light rays are traveling straight. And how do you see that? Is that, there are these dust particles which gets illuminated because of the light, and then you can see the light ray traveling straight. Okay. So rectilinear propagation means light travels in straight line. Reflection of light. Now let us understand what reflection of light means. So whenever there is a plain opaque surface, the light ray which falls on this surface, that light ray is called incident ray, which falls on that surface. The point at which this light ray is incident, that point is called point of incidence. And the light ray which gets reflected from this opaque surface is called reflected ray. At the point of incidence, the line which is perpendicular to this opaque surface is called normal to that opaque surface, right? So these are basic concepts which you need to understand. Okay. So incident ray, reflected ray, normal to the mirror or opaque surface, and the point of incidence. Okay. So the angle made by the incident ray with the normal is called angle of incidence, and the angle made by the reflected ray from the normal is called angle of reflection. So this angle is angle of incidence, this is angle of reflection. So angle of incidence will be equal to angle of reflection, which we'll see in the laws of reflection, which we are going to study now. So law of reflection, first law is that, second law in fact, is angle of incidence is equal to angle of reflection. Okay. So what are the laws of reflection? First law of reflection is that angle of incidence is equal to angle of reflection. Incident ray normal to the mirror at the point of incidence and reflected ray all lie in the same plane. What does this mean? This means that, if a light ray, so this means that if a light ray is going in one plane, incident light ray, and the reflected light ray, which is coming out of this, right, from the opaque surface, reflected from the opaque surface, all of this lies in the same plane. It is in the same plane. It will not happen that incident ray is going like this and reflected ray is coming out of the plane. It will not happen like that. So it will be in the same plane, incident ray, reflected ray, and all the normal. As you can see in this board, on this board, all of these lies on this board only. So it is going to be in the same plane. This is what it means, the second law, that incident ray normal to the mirror at the point of incidence and reflected ray all lie in the same plane. Is it clear, student? Is it clear to everyone? Okay, students. So let's go further. Now, how do you make a plane mirror, right? So making of a plane mirror. So what happens whenever you have a surface, you will silver it on one side of this surface. Let's say you have a glass plate, you are silvering it in one surface, and then on the other surface, what you are going to do, you are going to put behind, because when you silver it, there may be a chance that it may get scratched, right? Overuse. So what we do after silvering it, we do a red paint. We have a coating of red paint behind this silver mirror so that that silver mirror remains intact. So this is how you make a plane mirror. Okay. So, and the other side of that plane mirror will be the reflecting surface through which light can be reflected. Okay. The opaque surface is that surface on which you have done the silvering and you have colored it. And the reflecting surface is the other surface through which light gets reflected. So this is how you make a plane mirror. Now, let us understand the basic definition of reflection of light. What does reflection of light means? The process of sending back the light rays which fall on the surface of an object is called reflection of light. So, for example, you have a light ray, right? So this is the light ray. Let's say this is the mirror. So this light ray is called incident ray, and this is your reflected ray, right? So this process by which incident ray gets reflected is called reflection of light. Okay, so process of sending back the light ray which falls on the surface of an object is called reflection of light. Okay, you can note down this definition. The objects having polished shining surface reflects more light than objects having unpolished dull surfaces. So those surfaces which are shining, which are polished, they will reflect more light as compared to surfaces which are not polished, which are dull surfaces, which are not very plain. So in that case, the reflection is lesser. So silver metal is one of the best reflectors of light, and that's why we are doing that silver coating to make that plane mirror. So silver metal is one of the best reflectors of light. Clear? Ordinary mirrors are made by depositing a thin layer of silver metal on one side of the plain glass sheet, and the silver layer is then protected by a coat of red paint, as we saw in the previous slide. The reflection of light in a plane mirror takes place at the silver surface of it. So where does the reflection takes place? On the silver surface, that is on the front surface. Back surface is just to keep that silver coating intact. Is it clear, student? Are you able to understand this? How the silvering is being done and how the reflection is being done? Thank you, Raghavi. Okay. Now, types of reflection. There are two types of reflection. One is regular reflection and other is irregular reflection. Now, regular reflection happens by a smooth mirror, by a plane surface. So when the mirror is smooth or when the surface is smooth, then the parallel light rays which falls on it reflects parallelly. So you can see here the light rays which are coming parallel after reflection, they are again parallel. So this kind of reflection is called regular reflection. Now, what is irregular reflection? So irregular reflection, what happens? That it happens through a rough surface. It happens because of a rough surface. So here the parallel light rays which comes after reflection, they are not parallel. They will move in different directions. So you can see that incident light rays are parallel, but the reflected rays are in all different direction, and they are not parallel. So such kind of reflection is called irregular reflection. So there are two kind of reflection: regular reflection and irregular reflection. Reflection through smooth surfaces is regular reflection. So I'll explain it also. Parallel light rays incident after reflection is also parallel. So this is an example of regular reflection. And where regular reflection, after in irregular reflection, the parallel light rays after reflection is not parallel. It is in different directions. It is not parallel. So that is an example of irregular reflection. Is it clear? Regular reflection and irregular reflection. Is it clear to students? Okay. Okay, let's move. Now, reflection of light on plane mirror. So a ray of light is the straight line along which light travels. When I say, so we'll use this term a lot, a ray of light. So what is a ray of light? It is a straight line along which light travels. So the path of the light ray, because light ray moves in a straight line, the path of the light ray is called ray of light. So ray of light is the straight line along which light travels. The ray of light which falls on the mirror surface is called the incident ray. So for example, if this is the mirror, the ray of light, so and let's say this is the point of incidence, right? So this will be your incident ray. This is your reflected ray. This is normal. This is angle of incidence, and this is your angle of reflection. Okay, so the ray of light which falls on the mirror surface is called incident ray. So this is the ray which falls on the mirror surface. Okay, now this point O at which the incident ray, so point O at which this incident ray hits the mirror is called point of incidence. So this point is called the point of incidence. Okay, now the ray of light which is sent back by the mirror is called the reflected ray. So this light ray, which is going sent back by the mirror. So for example, if I say AO is the incident ray, OB is your reflected ray, and let's say ON is your normal. Clear? So normal is a line which is perpendicular to the mirror. So this is the line which is perpendicular to the mirror at the point of incidence, and this line is called normal. Is it clear, students? Okay, thank you. So a ray of light is the straight line along which light travels. So this we have already done, right? Angle of incidence is the angle made by the incident ray with the normal at the point of incidence. So we saw here, if this is our mirror and let's say this is the normal, right? This is the point of incidence, and let's say this is your incident ray and this is your reflected ray. So this angle which this incident ray makes with the normal is called angle of incidence. And similarly, this angle which this reflected ray makes with the normal is called angle of reflection. So the definition is angle of incidence is the angle made by the incident ray with the normal at the point of incidence, and angle of reflection is the angle made by the reflected ray with the normal at the point of incidence. Okay, so these are the two definitions which you need to remember for angle of incidence and angle of reflection. Okay, shall I move ahead? Now these are the two laws of reflection which we already saw it. We'll reiterate that. So first law of reflection states that the incident ray normal to the mirror at the point of incidence and reflected ray all lie in the same plane. And second law is that angle of incidence is equal to angle of reflection. So angle I is equal to angle R. This is your second law of reflection. Okay, I already explained it, that first law, what it means is that let's say this is a mirror and this is your incident ray, and let's say this is your reflected ray, right? And let's say this is normal. So, and this is angle of incidence, this is angle of reflection. So incident ray and reflected ray, they lie in the same plane. So you can see here on the surface on which I am drawing this figure, that is the plane. So on that plane only incident ray will be there and reflected ray will be there. It will not happen that incident ray is on the plane and reflected ray is coming out of the plane. That will not happen. It will remain in the same plane. Okay. The law of reflection are applicable to all types of reflecting surface. That means that when I say angle of incidence is equal to angle of reflection, what it means is that the law of this is applicable to plane mirror as well as spherical mirror. So we'll see what spherical mirrors are, in our next class. So here there are two kind of spherical mirrors. One is concave mirror and other is the convex mirror, right? So in both these mirrors also, angle of incidence and angle of reflection will remain same. So when we study this spherical mirrors, I'll tell you in detail what does this law of reflection means there. Okay, so let's go ahead. So it is applicable for plane surfaces as well as spherical surfaces. So plane mirror as well as spherical mirror. Last point is a ray of light which is incident normally on a mirror is reflected back along the same path. What does this mean is that let's say you have a mirror. So let's say you have a mirror here. So the light ray which is incident normally will be reflected along the same path. Why does it happen? Is because here also law of reflection is valid. Why? Because angle of incidence here is 0 degree and angle of reflection is also 0 degree. So that's why the ray which is incident normally means, along the normal, if it is perpendicular to the mirror, the light will reflect back along the same path. Is it clear? Is this point clear? That ray of light which is incident normally reflects back along the same path? Okay, students, thank you. Now let us understand what does an object and image mean. What is an object and what is an image? Let's understand this. So anything which gives out light rays, either its own or reflected by it, is called an object. So any object, any body which you can see here. Okay, so for example, this slide changer. So this is an object. Why? Because light ray which is coming from the light bulbs which are there gets reflected from this. So it does not has its own light, right? There are two types of object. One is luminous object and other is non-luminous objects, right? So we'll define here two more types of object. One is called luminous object and other is non-luminous object. So luminous is those which have their own light. For example, a candle, for example, a bulb, for example, a tube light. All of these have their own light and that's why they will be called luminous objects. Non-luminous are those which do not have their own light. So they do not have their own light. So what are the example of non-luminous objects? So non-luminous objects, every other object which does not have their own light are non-luminous object. For example, this is a non-luminous object. This pen is a non-luminous object. This mouse is a non-luminous object. So everything which you can see around which does not have their own light are non-luminous objects. Clear? So anything which gives out light rays, either its own or reflected by it, is called an object. Okay. So now, and an image is formed when the light ray coming from an object meet or appear to meet at a point after reflection from a mirror or refraction through a lens. Lens we are going to see later, but for now understand mirror. So when light rays coming from a mirror after reflection meets at a point, or it appears to be meeting at a point. So when it is actually meeting, it will be called real image, and when it appears to be meeting at a point, that will be called a virtual image. So there are two types of images. Okay, so there are two types of image. One is real image and other is virtual image, right? So real image are those images where which is formed by actually light rays merging at that point, right? So when light rays after reflection meets at a point actually, then we call it a real image. And when light rays actually do not meet at that point, but it appears to be coming from some other point, it appears, that means there is no actual light ray there. So that is a virtual image. So when we when we discuss about the image formation, it will be more clear to you when I talk about real and virtual images. Is it clear? Real image and virtual image, the basic concept, is it clear? Okay. So real image is formed when light rays coming from an object actually meet. So real image is formed when light rays coming from an object actually meet at a point after reflection from a mirror. So actually meets at a point after reflection, then a real image is formed, right? I'll not talk about lens right now. Lens, we'll take it up later. And the image which can be obtained on a screen, another definition, right? Because it is an actually light rays are merging, so you can take it on a screen, you can see it on a screen. So image which can be obtained on a screen is called real image. For example, in cinema screen, when you go to watch a movie in a movie hall, right, the image which you are able to see in front of you, those are real images, right? And real images, and that's why you can take it, you can see it on a screen. If it was not a real image, you will not be able to see it on a screen. Clear? Is it clear, students? Okay. Now let's understand virtual image. So what is a virtual image? So a virtual image is formed when light rays coming from an object do not actually meet, but only appear to meet at a point. So light rays actually after reflection, if it diverges, for example, right, we'll see the case right now just after this, that when light rays after reflection diverges, they are not converging, they are diverging. So in that case, when you see it, you will see the light rays you will see after reflection. When you see that image, it will appear to be forming somewhere, right? So such images are called virtual images. So virtual image is formed when light rays coming from an object do not actually meet, but appear to meet at a point when produced backwards. So when you produce it backward, it will appear to meet at a point. And that point is where the virtual image is formed. Okay. Image which cannot be obtained on a screen is called a virtual image. Virtual image cannot be obtained on a screen. One more thing you need to understand, real image is always inverted. So real images which are formed is always inverted. What does inverted means? Means if an object is, erect, the image of that will be inverted. Means top will go to the bottom and bottom will go to the top. So this is what inverted image means. We'll understand that in further classes as well. And virtual image, the virtual image is always erect. Okay. So real image is always inverted. Virtual image is always erect. This you have to always keep it in mind. So whether it is a plane mirror, whether it is a curved mirror, spherical mirror, this is always true that real is always inverted. Virtual is always erect. Is it clear, students? Okay. So plane mirror always forms virtual image. So plane mirror will always form virtual image. Similarly, a convex mirror also forms only virtual images, but this is what we'll read this later. We'll study this later. Right now, our interest is only with the plane mirror for this class. So plane mirror always forms a virtual image. Okay. Now formation of image in a plane mirror. How is an image formed in a plane mirror? Let's understand this. So let's say there is a point object O, right? So what was the definition of object? That object is that which has its own light or it reflects light which is falling on it. So for example, this object, there are two incident light ray which is coming from this object. This is one incident light ray and this is another incident light ray, right? Now, after reflection, this incident light ray will get reflected by following the law of reflection. So angle of incidence equal to angle of reflection. Similarly, here also angle of incidence is equal to angle of reflection, right? Now, these light rays after reflection, can you see that these two light rays, so if you see here, these two light rays are actually diverging, right? This is going in this direction, this is going in this direction. They are diverging. They are not converging. So when this person, when this observer, this is the eye of the observer, when this observer looks at the image which is formed, so this light ray will appear to be coming from this point. Light ray is appearing to be coming from this point, right? So when light rays appear to be coming from some point, that image is called a virtual image. When the light ray actually meets at a point, that is called a real image. So here, what image is being formed? It is a virtual image. Clear? So if you see this, if you extend it downwards, so what you will see that this person, this observer, he'll see that light ray is coming from this point I. So the object which is at O, the image is formed at I. And there are certain things which you can note here. One is the distance of the object from the mirror is same as the distance of the image from the mirror, right? So this distance will be equal to this distance, right? So distance of the object from the mirror is equal to distance of image from the mirror. The image formed is virtual, right? Is this clear to everyone? The formation of a point object by a plane mirror. The ray diagram, is it clear to everyone? Or do you want me to repeat it? Okay, good. Now lateral inversion. What does lateral inversion mean? Anyone of you, you can unmute yourself and you can tell me what lateral inversion means. Someone who wants to speak and tell what lateral inversion means?
Sir, if an object is placed in the right side now, the image should be on the left side. And if an object is placed in the left side, it will be opposite, vice versa. So it's like a mirror image formed of the object's place.
Yeah. Correct. Very good. So what happens, in case of lateral inversion is, so in lateral inversion, what happens? If I raise my right hand, right, in the mirror, it will seem that left hand is being raised, as in this case, right? So if I raise my right hand in the mirror image, the image will raise the left hand. So this is called lateral inversion. And this is the reason that, ambulance, which is written in front of the ambulance, is written in an inverted way, laterally inverted way, right? So that when the image is being formed, so let's say I am driving a vehicle in front of that ambulance, I will be able to see the ambulance written straight, not inverted, because it is already written inverted. It will get inverted and I will be able to see it straight. Is it clear to everyone? Lateral inversion. Okay, let's move forward. So image formed in a plane mirror. So let's talk about the characteristics of image which is formed in a plane mirror. Image formed in a plane mirror is erect and same size as the object. That means, let's say this is a mirror, right? So if this is the object, so the image formed will be of the same size. So if OA is the object, image formed, let's say OB will be the image, which will be, now this is erect. So this image is also erect and the size of the image is same as the size of the object. Is it clear? Now next, so you can see the image is erect and is of the same size as the object in this case. Second property is image is at the same distance behind the mirror as the object is in front of it. So the distance between the object and the mirror is same as the distance between the image and the mirror, right? So for example, here you can see that this is one chess which is kept here, and in front of that there is a mirror. So if you see this you know this particular thing which is kept here, so here the distance between the mirror and the object and distance between the image of that object is same. Okay. Now the third characteristic, if you see, image in a mirror is laterally inverted, as we discussed just now. So right hand becomes left hand and left hand becomes right hand in the mirror images. And the fourth is that image formed in a plane mirror is virtual. It cannot be received on a screen. So the image which is formed in a plane mirror, you cannot. So when you go back, let's say you go behind the mirror and try to see that object's image, you will not be able to see anything. Why? Because the image formed is virtual, right? There is nothing which exists behind the mirror. Okay. So image formed in a plane mirror is virtual and it cannot be received on a screen. Okay. So these are the four characteristics of image which is formed on a plane mirror. Now uses of plane mirror. So I'll quickly, discuss all of these uses. First, the plane mirror are used in our dressing table and bathroom. So basically you will see that we use plane mirror to see ourselves, to dress ourselves, right? So this is one of the main, one of the most important use which we come across is that it is used in our dressing rooms. So it is used in our dressing tables and bathrooms. Second, it is fixed inside the wall of certain shops to make them look bigger. So in certain jewelry shops, when you enter, or certain showrooms of cloth or garments, when you enter there, what you will see that they have put the mirror on all the walls. Why is it done so? Is that to give you an impression that the shop is very big, right? So even if it is a small shop, you will get you will get a feel that it is a bigger shop. So again, plane mirror, this is one of the use of the plane mirror. Third, it is used for making periscopes. Okay, so we use the plane mirrors in making periscopes. What are periscopes? Let us understand. So generally periscopes, we generally use periscopes in submarines, right? So what happens that, let's say there is an enemy ship here, right? This is an enemy ship which is here. So the light ray coming from this enemy ship, it will get reflected here. Incident ray will get reflected here. And then again, it will further get reflected at this point. And the observer will able to see that enemy's ship even from the submarine which is inside the water. So this is one of the use of the periscope. So is the concept of periscope also, are you able to understand what periscope is and how does it work? So all of this mirror is at 45 degree. Okay, similarly, this mirror is also 45 degrees. So both these mirrors, they are parallel to each other at 45 degree. And then light ray which is coming, this will hit at 45 and again 45. So this will become perpendicular. So light ray which is coming here, that gets deviated by 90 degree. Similarly, light ray which is coming here again gets deviated by 90 degree, perpendicular. Is it clear? Okay. So what we'll do, students, we'll continue with this class in the next class. So there are 2-3 more things which we need to discuss. Now let's conclude. So what did we do today is we understood what light is. Then we also understood the reflection of light from plane mirror, law of reflection of light, and characteristics of images formed by a plane mirror. We also did uses of plane mirror, and there is one small portion which is also remaining, which we'll cover it up in the next class. And in the next class, what we are going to do is we are going to study about spherical mirrors. And in spherical mirrors, the two type of spherical mirrors, that is concave mirror and convex mirror. Okay. So thank you, students. Thank you for joining in today. So next, when we meet, we'll continue this class. So this was more of, recapitulation of what you have already done in your previous classes. And in next class, when we meet, we'll study further about the spherical mirrors that are convex and concave mirrors. Thank you for joining in. Do tune in, keep on, attending the classes and learn from these summer courses, and, that will add value to your preparation. Thank you, students. Thanks for joining in. Bye and take care.